What's up, everyone, and welcome to the 36th episode of Super Brain Radio, the first installment of Chapter 8, Plasticity, which was strategically placed after Chapter 7. But from the subject standpoint, misfiring last chapter was all about invoking curiosity and awareness to the fact that specific areas of our brain can change. And it's not just age-related decline, it's more so that it seems to be that the brain is listening and adaptively changes. And if a stressor can align itself with time, this neurological organ, if you will, is going to exhibit change in maturation, in voltage dependent charges, and everything related to its actual function. And if you ride it out long enough, you're even going to see changes in mass in that neurological organ related to ones that it directly contraindicates. Because remember, guys, in the very earliest episodes, I exposed you to the fact that your brain isn't a light switch where the whole thing's on or off. Each brain area is sending communicative signals outwards to other brain areas about who and what needs to be done next and who and what is currently doing X. These are incredibly important foundational concepts to bear in mind as we talk about plasticity. And if we want to talk about what plasticity is and means, we need to now expose ourselves to today's episode, epigenetics. And I kind of want to start with just sheer exposure. If you've ever done anything like a weight loss journey, a fitness endeavor, or tried to learn a new skill or change jobs, you'll notice that the first couple of changes that happen in weeks 1 through 2 or 3 or 4 are vastly different than what's happening in month 3 and 4. And this is not just the law of things being mundane, of acclimation to stressors, of chronic exposure to stressors. We are actually looking at differences in function in areas of the brain that are associated with this task. And what you see in week 1 is also not properly just described by an alarm or sympathetic nervous system response. That doesn't accurately describe anything because we do see changes in skills in the first 1, 2, or 3 weeks. However, when we start to get more in depth and talk about how is the participant responding to the exact same stressor in month 3 and 4 in terms of progress, not in terms of recovery. Recovery is relatively linear, but in terms of progress, why are things different now? Why do we see things in the first place, like delayed onset muscle soreness, or the paradox that you grow best after doing something for X number of weeks? There are things that we know to be inherently true, especially in weight loss. When we talk about something like the hypothalamus or the thyroid, which are more relatively easy to wrap our heads around as far as their relativity to actual reality and applications of what you're doing in sports performance, we start to see that it's, again, this listening-based concept where the chronic stressor is leading the horse to water, and that horse being led to water is the neurological organ exuding plastic change. In the coming episodes, I'm going to expose you to types of plasticity, and we can be even more specific then. But what we need to be exactly on the same page about right now is that epigenetics is responsible for the motion of genetic flow, the communicating of it, and ultimately actual change itself. So if we were to start to unpack the term genetics, let's use this downward umbrella flowchart that we've used so many times in the past. Let's begin with putting genetics logically at the top and seeing what these subcategories of genetics are initially. We have heritable genetics. So these are the things that you directly inherit from your parents, kin, and long-term familial gene accruement. These are things like, your hair color, your eye color, your facial bone structure, the density of certain portions of your hips, so on and so forth. These are things that are pre-coded for. They are a part of you. You can't do some type of stress-based response that's going to make you taller in your 30s or make your hair color change out of nowhere. These are chemical responses. If you dye your hair, it's a chemical response to the hair change. However, it's not endogenously done by the hair. Obviously, the same applies for many, many things. But what we also need to realize are there are other types of genetics out there, and in fact, they're actually more responsible for quality of life and, like I said, the day to day motion of things than anything else out there. We have what I call day to day genetics, for lack of a better term. And these are epigenetic cascades, these are receptors, and these are, as well as SNPs and polymorphisms, everything that has to do with who codes what. So, for example, we have a parent DNA protein, non protein. Dietary amino acid protein, meaning it's not a protein that you're going to eat, but it still has a protein amino acid backbone. This DNA strand, if you will, is going to spark and code for other things, like the local receptors, depending on what it is. Same thing goes for SNPs and polymorphisms. They are going to be giving out instruction booklets to current and new employees, if you will. This happens over time. So the shelf life to your average receptor is anywhere from minutes to days, realistically. There are not many receptors that have a week's long shelf life, if you will. So something like a receptor is going to go through many, many fold more changes over your 16-week training cycle than, let's say, lipin 1 in the liver, which is a specific one that we target over longevity, but this is not going to respond in a mere 16-week training fashion. So we have all these different variables that go into the computing, if you will, of how you respond to X stressor, whether it be stress, skill accruement, whatever. What we're really now looking forward is to seeing how are things going to go there forth. And that's where we need to be putting our brain power, our perspective, and our future-based plans that have to do with periodization and getting to where you want to be in life. We're looking at epigenetic cascades proliferating over the long term. So now when we go backwards and we talk about whether it's an alarm phase, a sympathetic nervous system stress response, you initially being exposed to something new, and the laws of novel exposure mean you're going to see the most results from 0 to 1%, because 0 to 1% is an infinite increase, whereas going from 12% to 13%, you now have momentum, blah, blah, blah. What we also see is that when we want to go through initial change, what's actually happening in the first 4 weeks as far as how you feel or biomarker changes, it really doesn't matter so much. Because if you're planning long term, you're looking at epigenetic responses, and you're getting exposed to a stressor that's going to give you the epigenetic response you want. Therefore, the things you see in weeks 1 and 2, whether they're good or bad, are vaguely irrelevant. That's your initial immune response, specifically immune response to the stressor. Immune system adaptation is something that happens over time and has to do with recovery. And as I mentioned earlier in the episode, this is relatively linear, so you don't really have to worry about it all too much unless you want to focus on being hyper recovered to facilitate greater performance, but that's a bit of a different conversation. Again, it's the prediction model for the end outcome you want. If that end outcome is to build muscle, then you need to do something that is going to induce epigenetic change, and the epigenetics you're targeting have to do with muscle building. Now, when you can be that specific about things, you can also be increasingly simple and creative about others. So something like exercise selection or how you participate in your skill-based task may matter less if you are absolutely certain you might be looking for VEGF, a specific endothelial growth factor in this category. So it's an important concept not just to be aware of, but to actually attempt to define in your long-term journey. Now, that doesn't mean that you have to Google the human genome and learn everything about it so you can have something to chase. What it does mean is you should have an idea of maybe what types of cells you're chasing down and what a good and bad adaptation over time would be. And if you have an idea of that, which can be relatively vague, you can have a very good idea of how to plan properly. I've referenced the laws of second and third order action, and playing chess many, many times. And this is one of the underlying backbones and foundations of those analogies working so well. Now, this episode was a bit more in depth, so I'm going to leave it here and expect a lot of you guys to re listen to it, especially because epigenetics is quite a large category. But in the coming episodes, when I talk about what plasticity and change really are and attempt to define them in a truly accurate yet succinct fashion, you have to have a baseline understanding and at least awareness again of why are things changing long term over time and how is it happening. Again, it's this shedding of the skin, if you will, receptors being recoded for slightly differently, cells interacting with peptide hormones that code for them to function slightly differently, and so on and so forth.